Hello and welcome to Animated Education. Today we are going to talk about irrational equations. Probably the simplest example of such equation is a square root of x equal to some number, let it be 3. Now, what we need to do is we need to get rid of our square root. To do so, we need to square both sides. So let's do just that. Let's square both sides, and what we get now? We get that x is equal to 3 square, and that is 9. And this is our answer. Also, an important characteristic of irrational equations is that a square root can't be negative. And what is inside the square root also can't be negative. So it's important to check if our x is more than 0, more or equal than 0. That is very important. And x is 9, so it's true. And our answer is right. Okay, let's move to another example. Okay, let's say we have a square root of x plus 1 plus 5 equals to x. So, when we have such equation, the first thing we need to do is to isolate a square root. Okay, and when I say isolate, I mean that we need to leave it alone on one side and all other things must be on the other side. So, let's move this 5 to the right side and we get that x plus 1, a square root of x plus 1 is equal to x minus 5. Now, let's square both sides. And once we do that, we get that x plus 1 is equal to x minus 5 square. Now, we need to square these two numbers, and once we do that, we get x square minus 2 times x times 5 plus 5 square. There is a formula for that. For those who don't know, I'll just write that. A formula looks like this. If we have a minus b squared, it is equal to a square minus 2 times a times b plus b square. Okay, actually it's plus minus here. Okay, so now we need to group our similar numbers, and once we do that, we get that this will give us minus 10x. Okay, this will give us minus 10x. So let's move everything to the right side. Okay, so we get that 0 is equal to x square minus 11x minus 11x plus 24, because a square of 5 is 25. Now, all we need to do is to solve this equation, and we learned how to do it in our previous lesson. So, the first thing to do is to calculate a discriminant. So we get that 11 square minus 4 times a times c. So I'm saying a, b and c because of the formula, and this will give us 5 square. I'm writing it as 5 square because it will be easier to take a square root later. So our x is x1 is equal to 11 minus 5, a square of discriminant, divided by 2 times 1, okay, because here we have 1, and it is equal to 3 and our x2 is equal to 11 plus the square root of discriminant divided by 2 times 1, and it is equal to 8. Now, what is very important here is to check if both of our answers is right, okay? Because we get two answers and we raised equation by a power of 2, so it might be that one of our answers is wrong. So let's check it. Our original equation looked like this. X minus 5 was equal to a square root of x plus 1. Now, let's look if 3x equals 3 is our right solution. So 3 minus 5 is equal to minus 2. A square root is always positive, so this can't be right, and 3 is not our solution, so this is wrong. Now let's check if 8 is our solution. So 8 minus 5 will give us 3. A square root of 8 plus 1 will give us a square root of 9, and that is equal to 3. So x is equal to 8. This is the right solution. However, I want to show you how you can solve this maybe a bit easier. At least for me it is easier. So let's say we have our original equation, x plus 1, a square root of x plus 1 is equal to x minus 5. Now let's say that some number a is equal to a square root of x plus 1. Okay, and also let's change our equation a little bit. Let's say that our equation looks like this. Square root of x plus 1 is equal to x plus 1 minus 6. You see, I added 1 and I subtracted 1, so I didn't really change anything, but it looks a bit different. Now we can put this a instead of x plus 1 here. So a square would be x plus 1, okay? So we get that our equation looks like this. A is equal to a square minus 6. Now let's move a to the other side and we get that our equation looks like this. Now all we need to do is to solve it. We can use discriminant, but I would like to use Vieta's theorem for the sake of this example. You can try and solve it by using discriminant. So what two numbers could I multiply to get minus 6? It would be 3 and minus 2. 3 and minus 2. If I add these numbers, will I get 1? Yes, I'll get 1. So our solutions is 3 and minus 2. So let me write that. So a is equal to 3 and a is equal to minus 2. Now, because I said that a is a square root of some number, a must be more or equal to 0. So this is not right. So a is equal to 3. Now we need to go back and write that. So instead of a, let's put 3 here, and we get that 3, let me take another color, that 3 is equal to a square root of x plus 1. Now we already solved this type of equation as one of the very first examples. So we just need to take a square of both sides and we get that it is 9. 9 is equal to x plus 1 and x is equal to 8. So we got the same answer, so, and we know it's right because we already checked it, but we got it a lot faster At least I think that we got it faster, and you don't need to check yourself because you know that you got the right answer. So that also saves time. So yeah, let's move to another example. Now, just as we solved in our last lesson, we need to say that our numerator is square root of 5 minus x squared minus x plus 1 is equal to 0, and our denominator is not equal to 0. So now let's solve this system of equations. Okay, so we get that we need to move this minus x and 1 to the other side. So let's do that. Now we isolated our square root. Now we need to square both sides. Okay, so once we do that, we get that 5 minus x squared is equal to x minus 1 square. Now this will give us that 5 minus x squared is equal to x squared minus 2 times x times 1 plus 1. I used the formula again. If you forgot it, you can check because I mentioned it earlier in the video. Okay, so let's move this x squared to the other side as well as 5, and we get that 0 is equal to 2x squared minus 2x minus 4. Now we need to solve this quadratic equation, so let's calculate our discriminant for that. Actually, before doing that, we could divide it by 2. This would help. So let's rewrite it. X squared minus x minus 2 is equal to 0. Now once it's reduced, we could use Vieta's theorem, but I already used it earlier in the video, so let's just use discriminant this time. So discriminant would be b squared minus 4 times 1 times minus 2. This will give us 9, and that is 3 squared. Now x1 will be 1 minus 3 divided by 2. This will give us minus 1, and x2 is 1 plus 3 divided by 2, and that gives us 2. So our equation, let me rewrite that equation. So our equation is equal to 0, then it is then x is minus 1 and x is 2. So however, x can't be minus 1, because if I put minus 1, this our denominator will be 0. So our answer is 2. Our answer is 2. Let's say we have x plus 8 minus the square root of x minus 8. X minus 8 is equal to a square root of 8. Now, what do we do in this case? So I would suggest to isolating the square root. So let's move this square root to the other side, so there wouldn't be any minuses here. It would make our algebra easier. So this is what we get. That's a plus sign. Okay, so now let's square both sides, and we get that x plus 8 is equal to x minus 8 plus a square root of 8. Okay, so we need to open this. We'll use our formula again, and let's just do that. X plus 8 is equal to x minus 8, okay, I'll use parentheses so it will be more clear, plus 2 times x minus 8 times a square root of 8 plus 8. This is what we get. Okay, so we could subtract 8 from both sides, and this 8 will cancel. The same goes for x. Okay, so this x will cancel. So let's move this 8 to the other side, and we get that 8 is equal to 2 times a square root of 8 x minus 8 times a square root of 8. Now let's divide both sides by 2 square roots of 8. This will give us that 8 divided by 2 square roots of 8 is x, a square root of x minus 8. Now this in fact will give us 4, and a square root of 8 is actually 2 square roots of 2, because a square root of 8 is basically a square root of 4 times a square root of 2. So we get that this will give us something like that, and we will rewrite this side. Now let's square both sides, and we get that 4 divided by 2, because I squared this, is equal to x minus 8. Let's move 8 to the other side, and we get that our x is equal to 2 plus 8, and that is equal to 10. So our x is equal to 10. Of course, I would suggest checking if our answer is right, but in fact I already did that. Let's say we have x minus 3 raised by a power of 2/3, and that is equal to 4. So what do we do now? We need to raise both sides of an equation by a power of 3 divided by 2. Okay, so let me write that. X minus 3. Now let's raise it by 3 over 2, and it is equal to 4 raised by the same. Okay, so this, let me take another color. This will give us 1. So because we need to multiply these two and these two fractions, and that is 1. Okay, so this is x minus 3, and once we took a square root of 4, this will give us a 2. So, and 2 by the power of 3 is equal to 8, and x is equal to 11, because 8 plus 3 is equal to 11. Okay, so I think that's enough for this time. I hope you understood everything, and see you next time.